Welcome to Brain Vision.
Okay, so in this problem, we are trying to figure out the mass of NaBr in grams. So we can always set up a system of equations by adding in the mass of one mixture and adding in the mass of a second mixture. And we know that's going to come out to the total mass of the mixture combined. And in this case, we know that is going to be 2 grams. 2.00 grams. So in the case of this problem, I'm going to let M1 represent the mass of NaCl, and I'm going to have M2 be what we're trying to find out, the mass of NaBr. Now, one other thing we know about this problem is that this mixture is going to contain 0.75 grams of sodium. And we know that sodium, or the Na, is going to come from both NaCl and NaBr. So we need to set up an equation for the Na, or sodium content, within the whole mixture. So to do that, we are going to say 0.75 grams of sodium is equal to the mass fraction of our sodium in NaCl. We're going to multiply that by the mass of mixture 1, and that is going to be added to the mass fraction of sodium in NaBr. And since that we labeled as M2, we're going to multiply that by M2. So we know that the mass fraction of sodium in NaCl is going to be the molar mass of sodium divided by the molar mass of NaCl. And we're going to do the same thing for NaBr. So we have 0.75 grams sodium is equal to, and I'm going to use brackets to make this more clear, 23 grams per mole divided by 58.5 grams per mole. And that whole thing is going to be multiplied by M1. Then we're going to, again, do the same thing for NaBr. We have 23 grams per mole divided by 102.9 grams per mole. And that is going to be multiplied by M2. So we can actually use this equation up here to find a substitute for M1 in this equation that we just created. So if we manipulate this equation up here a little bit, we can say that M1 is equal to 2 grams minus M2. So we are going to fill this in for M1 in this equation we just created down here. So that is going to be 0.75 grams of sodium equal to 23 grams per mole divided by 58.5 grams per mole. And here we're going to multiply that by this equation we created up here. So that is going to be 2 grams minus M2. And then that is all going to be added up to this part that we already created up here. That's going to be 23 grams per mole divided by 102.9 grams per mole times M2. Okay, so now we just have to perform some calculations. So we've got 0.75 grams of sodium is equal to, if we divide 23 by 58.5, which we can do because we're using the same unit of measurement here, that's going to come out to 0.3932 times that equation we created for M1, that's 2 grams minus M2. And we can add that to this over here once we divide that, coming out to 0.2239 times M2. Now I'm going to bring this down and distribute this into our 2 minus M2. So that is going to give us 0.7864 grams minus 0.3932 with the M2 attached to it, plus our 0.2239 times M2. Now we combine our like terms. We've got 0.75 grams of sodium being equal to 0.7864 grams minus 0.1693 times M2. So now I'm just going to subtract this 0.7864 grams from both sides. So when we do that, we get minus 0.0364 grams being equal to negative 0.1693 times that M2. So now I'll just divide both sides by this to solve for M2, which again, a reminder, that's the mass of NaBr, and that's the whole thing that we've been trying to solve in this equation. So once we do that, we get M2 being equal to 0.2153 grams, and that's going to actually be, let's use an approximate sign because we're rounding here. So this is going to be the approximate mass of NaBr in your mixture.